Engine Performance 1 Test 14. Which sensor is used to determine the temperature of the engine? Duh, that's the engine coolant temperature, ECT. The J1930 regulation says everybody's got to call that the same thing. What term is used to describe a sensor that has less electrical resistance as temperature increases? If it's got less electric, see, that's backwards than what you expect, remember that? So what do they call it? You remember that term?
Positive and negative coefficient.
All right, so what's the answer going to be?
I think it's going to be a positive temperature coefficient.
No, what? No, positive is what you expect. Negative is what you don't. You remember what I'm saying? You expect it to get more resistance as it gets hotter. These sensors that we have here that we're using get less resistance as they get hotter, so it's negative temperature coefficient.
All right, so
the sensors are all negative temperature coefficient typically on these things. If the sensor gets less electrical resistance as the temperature increases, that's the opposite of what you would expect. Like when a copper wire, a battery cable gets hotter, it's going to have more resistance, right? So just remember that way. Positive is what you expect, negative is what you don't. That's how I always remember that. Everybody's got to have a memory bug, right?
yeah, because
you don't get those crossed up. What is the term used to describe a PCM function that uses the high and low resistance circuits for the same input for a more accurate reading of engine operating temperature? Now that is a sort of a dumb question, the way they've worded it. But you remember how I told you about stepped circuits? You're going to have a engine coolant temperature sensor. If you go to the Oldsmobile, and it's got a good temperature sensor on it and the connectors aren't spread and all that kind of stuff, but we worked on that one a lot. That's the one that I was thinking about. You fire that thing up, you're going to see the engine coolant temperature sensor voltage go down, 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 down if you're looking at voltage, and then all of a sudden it's going to jump up and it's going to go down again. It's going to look like a sawtooth, and that's a stepped circuit. And that's actually handled inside the engine controller. Technician A says the ECT and IAT readings on a scan tool should be within 5 degrees of each other if the vehicle has not been driven and the engine is cold, and Technician B says the PCM will deliver more fuel and call for more ignition timing events with a cold engine. Who's correct about that?
I think B is right at least.
A is right, because if you switch on an engine, the second law of thermodynamics says that if the engine hadn't been run for a while, the temperature of the air and the coolant should be really close to the same, right? That's just life in the big city, or just on Earth, whatever. And then Technician B says it's going to deliver more fuel and call for more ignition timing events with a cold engine.
Does it run richer when it's cooler?
Yes, and you think about your choke on a carburetor.
Yeah.
So your choke on a carburetor is going to be closed when it's running cooler, and also the timing advance is going. Your time is going to be advanced. Now something else that happens up there in high altitude. You know, in high altitude you're going to be running with less fuel and more timing advance. So for high altitude you advance the timing and you cut back on the fuel. Because the air is thinner, you have less air and you need less fuel. Got it? You don't need as much fuel if you ain't got as much air. If you've ever driven a car, like just a plain old carbureted car, and gone to the mountains on it, you'll be plumb ashamed of it because it won't even hardly pull a hill unless you advance the timing.
Why the timing advancement? Is that because it
takes longer to burn when there's not as much oxygen? Oxygen accelerates combustion.
Yes.
So if it's less oxygen, it's going to take longer for it to burn, so you got to have more timing advance. And that actually moves the window. So your timing advance is there so that it can let the spark happen, the combustion event has to happen at the proper time so that your piston gets the maximum benefit of that punch. See? And imagine what happened if you're hitting it too late. You know you're not going to have as much oomph in that punch, and it's going to be hitting it at the wrong time. That's why late ignition timing makes a vacuum low and it makes it run crappy too. You know, you won't have as much power. And when you have cracked the throttle, the timing advance is going to advance. You know, time is going to advance. What voltage does the PCM typically use as a reference voltage?
12.
Think about it. Reference voltage for sensors. We've talked about it a zillion times. How many volts do you usually see on the reference voltage wire on your throttle position sensor, for example? What's your voltage? 5 volts. Daniel holds up his hand. There you go. Okay, you got that. Always remember that's 5 volts. Now, I will tell you this. You probably won't ever be working on something like an 83 model Lincoln Town Car, but if you're ever working on one of those, the reference voltage is 9 volts. That's what they started out with. And throttle position sensor voltage at closed throttle was 1.8. Well, on the 5 volt, you know, it's like 20% of the throttle position sensor closed voltage on a Ford would be 20% of the maximum, more or less. Of course, you know, anyway, this is 5 volts on those cars. I could really go off on that for a while. What type of sensor has 3 terminals with one connected to a movable contact that slides across the resistor to vary its resistance? Potentiometer. What sensor is the most common potentiometer? The one we talk about all the time. Which one? Do you remember? You guys should know this now. I've covered this 788 times in class. Throttle position sensor. Right here. The throttle position sensor is the one that's the most common potentiometer. The second most common potentiometer is the one that's found in the EGR valve that tells the computer where the EGR valve is. The linear EGR valves. The Bronco that we've got out there has got a sensor sitting on top of the EGR valve. It's a linear potentiometer. It's got 3 wires going to it, and 0.4 volts is what it's supposed to read when you're going into the signal wire at rest. And if you start getting EGR and it starts moving it, it'll go up. Okay, that's a feedback. The following statements are correct except, you know, and I don't want to read all these that aren't correct because it'll get you confused. But you're supposed to be able to parse those and figure it out. Let's go ahead and read A. The PCM will turn off the AC compressor if the throttle is depressed all the way. That's right, isn't it? That's wide open throttle cutout of your AC compressor.
Why does it do that?
Because it wants you to have a little bit more power when you're passing the semi going up a hill. All right, the PCM reduces fuel injection pulses when the throttle is depressed all the way when cranking the engine. It actually shuts the injectors off, is what it does. And the TP sensor is used to control transmission shift points. That is correct. Now here's the one that's not right. The PCM reduces the fuel injection pulses when the engine's cold. Stands to reason if it needs to run richer, it's going to have increased pulses when the engine is cold. And here's something else. When you're spinning that engine over, it's going to double pulse the injectors to wet the manifold. That's the same thing you did when you hit the gas on a carburetor, is you had to wet the manifold and close the choke. That's what gets the engine started. The engine controller has still got to wet the manifold even on a fuel injected engine. So it's going to, the injectors are going to go poof, poof, poof. They're going to be popping all together while you're cranking. And then whenever you start it up, then they start firing with less fuel.
What about on a GDI engine? Gasoline direct inject?
Oh, the GDI engine, they all got the same criteria. I mean, a cold engine is going to have more gas while it's cranking. That's just the way it is. And those, they actually, they've got super high fuel pressure on those things too. As a matter of fact, when I go to KC Vision in March, I'm supposed to be, I'm signed up for a gasoline direct injection class. So I can get a little bit of a, I hadn't ever worked on one of those, and I read about them, but you know, I'd really like to get my hand. And it's actually a shop class where we'll be able to go in there and do that. And if you guys want to get off of $1,600 or $2,000 for airfare and ticket, and you could probably go up there with me if you wanted to. You know.
I could make the VA pay for it, I'd go.
Yeah, well, we'll write them a letter. All right, now then, let me see. We'll figure out where I'm going. What is the maximum value allowed for the voltage drop of a sensor ground circuit? Sensor grounds are 200 millivolts, believe it or not. For a sensor ground circuit, you should not have, and do you remember how you check voltage drop on a sensor ground circuit? Remember? Let's do this. Watch this. This right here is your PCM. This right here is your sensor. You got 3 wires. You got me? Unless it's a 2-wire sensor, and then you'll have 2 wires. All right, you got that? Okay. Now this one here, let's say this one here is your 5 volts. This one here is your SIG. And this one here is your sensor ground circuit, which will be signal return. That's a ground that's coming out of the computer. And this one here is going to be the one that's going to go up and down when you move your throttle or whatever. Okay, so you take your meter with everything that's key on and everything happening. And you take your meter, you remember what we talked about. You're going to hook it here, and hook it here. While all that's going on, you shouldn't see over 200 millivolts, and you better have a good meter. One that you know is accurate.
And that's exactly what we had to do on that course. That's the exact system.
So what we're trying to do is make sure that we're not losing anything between here and here. You know, if you've got resistance, maybe like a terminal crimp that's begun to oxidize a little bit, if you've got that. And we've seen that before on throttle position sensors. When you let off your throttle, it's supposed to, see, whenever you first start an engine up, the first thing it does is it wakes up and it looks at that throttle angle, the first one it sees, and it says, that's closed throttle, right? And let's say that it looks at that and it sees 0.95 volts, all right? All right, now let's say it says, okay, since I know this is idle, this is going to be my benchmark for idle. So I'm cracking off of the 0.5, I'm cracking off this 0.95, and it's going to classify this as CT, closed throttle. All right, anything above like 2 or 3 millivolts above that, it's going to classify as part throttle. If it goes all the way to like 4.6, it's going to call that wide open throttle. Like that. But this right here would be like anything from about 0.97 or 0.98 up is going to be part throttle. Now, what does it do? Listen, this is important. If I won't tell you this now, forget it. And this is where we need to be. If I'm giving it that, and the older carburetors, I've talked about this a little bit before, you'd have a little thing, it looked like a funky little diaphragm with a spring on it, and it would rest against the throttle plate on a particular place, and when you give it the gas, this thing would ease out. And then when you let off, it would catch that, and the throttle would slowly push it back in. That's called a dash pot. If you just let the throttle plate slap all the way shut without going through, then what happens is there's a little transition time there that before the engine's coming down, it'll stall. And that's true on fuel injection engines just like it was on carbureted engines. That little dash pot I was talking about, it looks kind of like this right here, and it's got a little plunger out, and it may have a little spring on it here, it may not, and the throttle plate sits against it, and it's bolted to the side of the carburetor, and it lets that come back in slowly. Well, on a fuel injection engine, what happens is when you let off that gas, when you give it gas, the idle air control goes wide open. As a matter of fact, you're not idling, it goes wide open. And you let off the gas, it comes back down slowly. You'll see it if you're looking at your scan tool. You'll see it when you go, it may go to 100% or really high. The steps may go way up. And then when you let off the gas, it comes back down slowly. That's a universal thing that typically happens. On your electronic throttle bodies, it does it with the throttle plate, so they don't have idle air control on those. But one way or another, I've seen that where we had voltage drop on the signal return circuit on the throttle position sensor. And whenever you would give it gas, and it would only happen after it got hot. And when you give it the gas, and it was up here, when you let off the gas, if you let off kind of slowly, typically, it might come down and it might hang up on 0.99 or 1.01, just a little bit higher than what it had already classified as closed throttle. And then what happens? The idle air control stays up because as far as it's concerned, the computer's concerned, you haven't let off the gas. And so what you have there is, wah, engine won't idle down. Somebody says, I'm pulling up here to a stop sign, I've got my foot on the clutch, on my stick or, and it's still trying to run away. What's up with that? And so you look in your idle air, if you look at your scan tool and you see that when I've let off the gas, I'm seeing it'll see PT or CT on the scan tool. If it shows me higher voltage than it classified, and it'll show you a little PID for closed throttle voltage. If you've let off and it's still higher than closed throttle voltage, that's your problem. Now it'll either be a bad throttle position sensor, or I've actually taken these little crimps and soldered them. The crimps may look good, and I just solder the crimps. And when you solder them, all of that little bit of oxidation goes away. You may not see anything wrong. It may look like brand new wire. But we'd unkey the connector that plugs into this TP sensor here. We would unkey that, pull make sure you remember which cavity these little suckers go in, let them stay in their little rubber seal, and mark the one that goes where. You don't want to put them in there wrong, of course you probably won't anyway. And have the wires sticking up. Don't let the wires hang down in solder, because what happens to the solder, Danny? It goes down, and then you screw up the connector. Now you go find one of them. If you give them up and you just solder the little terminal crimps, then you're good. You put it back together, and you know what the best part about that fix is? It doesn't cost anything to do it except a little bit of solder in a few minutes time, and you'd be surprised how many of them you'll fix that way. My daddy's Tempo had a problem, and it was throwing us mass airflow sensor codes, And he had already got a mass airflow sensor and didn't fix it. And so I took them little things out and I soldered them up, and all them, the mass airflow code went away, you see. So it won't be, it's not just throttle position sensors will cause them. It's really amazing how that works that way. But anyway, just remember that, because if you've got voltage drop on that, if this has got voltage drop, it's going to cause the signal voltage to be higher. Let me ask you this for a second while I'm here. What if I'm reading 1 volt right here, and I'm reading 5 volts right here, and of course I'm obviously reading 0 volts over here, because it's a ground, right? What if I cut that wire? Where does this voltage go?
What?
If I cut the ground.
Goes 0.
No, if I cut the ground, it goes to 5. Yeah, because there's no ground anymore, and it's just going straight through there. Because see, what you got over here is you got this little thing right here, and the farther this little contact slides toward ground, the lower the voltage goes. If it ain't got no ground, you're reading the full 5 volts all the way through the range. All right, what if I wanted to be a jerk, and I went out here on the engine controller, and I extracted pin number 90, I think it is, that's the, like on that Ranger or something, and all of a sudden your engine controller doesn't have any signal return at all. Every sensor on that truck's going to be reading top of its. So if you plug in there and you see that every sensor itself is reading all the way to the top, you say, wait a minute, do I have good signal return? And so that's when you go over here and you check for a ground on your signal return wire. That way, if there's not one there, you need to go back toward the engine controller. I've either cut the wire or I've pulled the pin, and you may, and I'll probably hit.
A size smaller than that
Oh,
one.
a size smaller. Okay. Okay. It really makes me sick that these freeze plugs are made in China. Hold on a minute. Find me my phone. I wonder if he's already putting them freeze plugs in. We need to clean that rust out of the block before we do that.
No, we're going to take it outside and flush it first.
Yeah, we need to do that. Okay.
Don't miss that.
Yep. Here, I mean, you're not putting the freeze plugs in it yet, are you? Okay.
I was just going to make sure that was right side before I knocked the other one out. I mean, it's going to have to come out anyways.
Talk to Brett. If Brett don't answer the phone, ask for him. Okay. Tell him who you are and where you're at, and I told him to call you. All right. Now then, let me say, which sensor is used on many engines to determine engine load?
Manifold absolute pressure.
MAP, yeah, the MAP sensor. It also works in conjunction with your GPS to figure out where you're going. No, I'm kidding.
That's mostly a Chrysler thing, but does Ford fool those any?
Well, I'm going to tell you the truth. A lot of engines have them on them, and they'll have mass airflow now.
Yeah.
Like, for instance, our Oldsmobile is a 97 model. It's got a MAP sensor, and it's got a mass airflow. So it's basically, I believe that on some of them, and I'm just talking out of my hat, but I believe that it probably is using it for a feedback for the EGR, a secondary feedback. Years ago, the feedback for the EGR used to be the oxygen sensor.
I'll knock that one out and let him take it. And
sure, that's no problem. But anyway, MAP sensor's right. Manifold absolute pressure. And here's another thing. Manifold absolute pressure and engine vacuum, if you add them together, add up to barometric pressure. So if your barometric pressure is, 30, and you're going to have 18 inches of engine vacuum, you'll have, 18 inches of what you're going to call engine. The pressure is going to be 12 inches. The engine vacuum is going to be 18. So remember, if you add those together, you're going to get barometric pressure. That's the way how that works. What term describes a sensor that changes its resistance in response to pressure? Piezoelectric. Piezoelectric. That's a sort of quartz thing. What does quartz do when you apply pressure to it? Creates voltage.
Oh.
You know these little snap things on your lighter where you snap your lighter and it makes a spark and it lights your flame? That's a
Flint.
Yeah, it's like a quartz thing. No, not the flint. The flint thing scratches, that little.
Oh, you talking about?
I'm talking about the one that snaps and it makes a little spark.
Yeah.
And you can take that little spark and that one there's no, that one I think has got a regular spinning wheel. The one that goes, yeah, the one that goes pop, and it will shock you. And there's a big old guy that I worked with that I like to tell stories about named Philip, and he looked like a grizzly bear, and he had lightning fast reflexes, and I used to come up there shock him with that thing, and then trying to get out of the way for him. He hit me 6 times. You know, he was that fast. He was like lightning.
That one to fit inside that one.
Yeah. Second rate amateur.
We're gonna do the heads too.
What size you reckon it is?
Well, I don't know off the top of my head. It's a 20 millimeter or something. I don't know. See that? What's that on there? This one right here is actually 1 3/8. That's going to be 1 1/4, I imagine. You can measure it with a tape measure.
That's what I told him. Anywhere from 1 inch.
Hey, Santa. You doing okay? Yeah. All right. All right. Technician A says the map reading for a healthy engine and idle should be about 1 volt. Technician B says some map sensors generate a digital frequency signal. Both those guys are right. Okay, the following statements are correct except, let's start from the bottom and read up. The map sensor can be used to monitor EGR operation. Yes, and the reason for that is engine vacuum goes down, you know, changes when you start flowing EGR.
The engine has to be under a load for EGR to do.
Yeah, it actually needs to be, if you're wide open throttle, it doesn't work, but if you're in anywhere in between idle and wide open throttle and the engine's warm, it's supposed to be working. Used to they did canister purge and EGR at the same time. Now the canister is liable to purge anytime. It may purge when you're idling. All right, now then, the map sensor can be used to determine engine load, and it can, and that's the most important thing they used it for a long time. The map sensor can be used to determine sudden deceleration. That's true too. And as engine manifold vacuum goes up, map sensor will show increasing voltage, and that's the one that's not right.
It should decrease.
The vacuum goes up. All right. Technician A says a defective map sensor could cause poor fuel economy. He is correct. Something else a defective map sensor will call, if it tells, it also doubles on most vehicles as a barometric pressure sensor, with the exception of that Nissan that we were just trying to put the engine controller on, because it had a little barometric pressure sensor just mounted there with the engine controller. It looked like it had a little place for a vacuum line, but nothing was plugged into it. It used that for barometric pressure. On some of your Ford diesels, the barometric pressure sensor is in the dash behind the instrument cluster, which was an odd place for it to be. You know, they used to put it out there under the hood.
Why would it?
I don't know. Don't ask me. Some of them is built into the engine controller. It's actually a part of the engine controller on some vehicles. But just be aware of that. But anyway, the barometric, and some of them use the mass airflow to do it.
Certainly it's got something on the engine though that for input.
Well, no, barometric pressure is the only input it's looking at.
Actual.
Yeah, the actual barometric pressure is what it's using for that. If that thing starts telling a lie, well, the map sensor, when you switch it on, they'll ordinarily they can figure that out. The engine controller can interpolate that information as, okay, the barometric pressure is so-and-so. If it's telling us that it's at altitude when it's not, it's going to make it run lean and it's going to idle rough and all that. I don't know how many times I've replaced map sensors for that. Even the ones, well, this is a little story. Donnie had this Jeep he was working on, throwing lean codes, oxygen sensor, flatline, fuel trims are plus 25 and all that. So he throws an oxygen sensor at it because he feels like it must be what's wrong with it because they fail a lot. And me and him went and drove it together just like it would. Didn't change a thing. And so I got to looking at his PIDs and I says, Donnie, the barometric pressure that your map sensor is reading looks like it thinks you're at 5,000 feet. And so he put a map sensor on it and cleared it up. I've got that map sensor around here somewhere that I could, you know, put on my Jeep and show you what it does to the fuel trim. But if your fuel trim is way off to the plus side, you need to be looking at your barometric pressure sensor wherever it's at and make sure that it's reading. But if there's a hurricane coming or something else is going on, you need to recognize that it's going to change. So compare a couple of cars if you've got a reading that's really screwy and say, well, both of these, or maybe have a barometer on the wall or something like that.
Yeah, so if you tried to leave last minute during a hurricane was coming, say you just want to leave last minute, that could cause some issues with your vehicle being close to it.
Well, not really. Your vehicle is going to alter air-fuel mixture based on barometric pressure. And if it's telling the truth, they won't have a problem. But if it's lying about it, you know, if you're used to seeing about barometric pressure of about 29 to 30, and all of a sudden you're showing 26, And you're thinking, hey, I got a bad map sensor. And then you put it on there and it's still reading 26. You say, wait a minute, let me see what the barometer says. And oh, well, the air pressure's low today, you know. Thunderstorms, you know, when they're coming. Do you know what causes deserts?
Lack of moisture in the dirt.
That's close. But I mean, you're close, but there's a phenomenon. You might notice that within like between 10 and 40 degrees north latitude, and sometimes in the southern part of the hemisphere too, or the south, you'll have deserts like the Sahara, the Mojave, and these deserts like this. That's caused by a planetary phenomenon called subtropical semi-permanent anticyclones. And that's masses of high pressure air that just kind of hang there on that particular, because of the dynamics of Earth's rotation and everything else. They just hang there in that one spot. And they pretty well keep the rain away. Just that, you know, rain can't go in there, you know. But that's what just remember that term, subtropical semi-permanent anticyclones. They're in the subtropics, which means they're not in the tropics. They're just off the tropic. And they're usually there, but not always. And anticyclones means that thunderstorms and stuff can't get in there because the pressure keeps it pushed away. See, that's not too terribly complicated, but that's a meteorological thing. The only reason I know that is because my mother had a book she got from somewhere, a coffee table book on deserts. And I got reading that thing. I did the Sean thing. I was reading it, absorbing, you know, useless information that nobody else needs. I do like you do. I gather stuff like you do, and I store it up here, you know. And if I was ever on a game show, they would never ask me about any of that stuff, and I'd probably crash and burn. Yeah. But if you throw a lot of trivia around, people think you're really smart when you're not. You know what I mean? You ever notice that? All right, now then, let's see. Technician A says a defective map sensor could cause poor fuel economy. Technician B says a disconnected or clogged vacuum hose could cause a diagnostic trouble code for the map sensor. Both of those guys are right, and you'd be surprised how many times you see those. Which type of sensor? Hey, I get hit by tickets. Which type of sensor uses a potentiometer to report airflow to the PCM? Ooh, that's a good question. Vane airflow. It's got a little flapper, L-shaped flapper, and the air moves it, and it's got a little potentiometer connected to it. That's the old Bosch L-Jetronic fuel injection that was the scourge of the 1980s.
Those not very common now, I guess.
Very, very seldom do you see a car with that on it. And I'll tell you something else. One time I was going to get a vane airflow sensor for a Toyota that we were working on over here that was an older one, and they wanted $1,000 for that dadgum thing. Ridiculous. Anyway,
they were proud of that thing.
They were, and they wanted a lot of money for it too.